What's up? What's up? It's October. I love October. So, maybe some Halloween jokes. What is a vampire's favorite fruit? Nectarine. 'Cause- All right, you're going to need your workbook. So, if you don't have those, please make sure you pause the video, grab them out of your backpack. You're going to open up to page 13 and 14, and let's get started. You're either doing this on your own or you're doing this because you failed a mastery check. It's okay, don't worry. You're going to be great after you do this, and then you'll come back and see me. All right, so we're going to look at particle movements for solids, liquids, and gases. And with your pen or pencil, first thing you're going to do is for solids, we're going to be focusing on um, shape and volume. And so the particles are in a solid very close to one another. You'll make sure to underline that. And solids actually vibrate. And you can see from, oh, there we go. They vibrate right there. For liquids, now liquids move around a little bit more. Their particles are, let's go ahead and get this, they are close to each other, not very close, but close. They move around randomly. It's going to do move randomly. And as far as their motion is, they can collide with each other, and that's how it's easier to pour liquid from one container to another, or pour your drink from your cup into your mouth. Now, gases, they move completely differently than solids and liquids. Gases, their particles are widely spaced. There's lots of space, and they move around randomly. They move randomly at high speeds. So pause if you need to. All right, clear that screen. So as you see here, these are solids, and you can see how they have one line around them to show that they do vibrate in place. For those of you that keep asking, when do they stop moving? That's going to be absolute zero, which I believe is about negative 473 degrees Fahrenheit. Liquids, you can see they have two lines, and they're closer. They are close. They're not the closest, but they're close, but there is more space in between them. And then over here, you can see that there are three lines when it comes to gases, and they just move randomly. They're bouncing in whichever direction that they go. Now, on your next page, I'm going to go ahead and close this, and we're going to open up this one here. No, I just want to open that up. There we go. All right. So this is going to be a little bit more confusing, so I'm going to help you out for sure. It says explain how the observable function. So that's kind of what you see in your model, or the properties of solids, liquids, and gases are related to the unobservable structure. So what their job is when it comes to their function, their shape, and their volume, how does that relate to their structure? So on this page in your workbook, you're going to go ahead and you'll type in the things that I'm typing in. So first thing here, it's saying, if solids hold their shape like a table, like an apple, like a jar, what does that lead to, like in their structure? And that makes it so pieces do not fall off. Or you can write that the particles stick together. Either one of those is just fine. Now, the function of liquids are to flow from one container to another container. And how does that help with this, with the structure, or how is that related to the structure? Well, because they flow, they can move from container to container. I thought I'd take a little pause. Maybe it would help to see this. So because the particles can flow in this glass of juice, it makes it able to have their structure. I went from the glass filling up this shape. Now it's filling up whatever shape that it's poured into, my esophagus all the way down in my stomach. And for gases, their function is that although they flow, they can also be compressed, they can be squished. So the structure of that is going to be that they can be squeezed into smaller places. And so the function is definitely related to the structure of how those models work. Now that you've finished with this, please make sure to study a little bit more for your mastery check and then come up and see me. Oh, and you need to bring your workbook with me so I can see that you did the work.